Good day, students. Welcome to mathcodeserve.com. In this clip, we're going to be going over questions 26 through 30 of the Thea practice test for mathematics. Don't forget to visit our website at mathcodeserve.com for access to a wide variety of math tutorials ranging from algebra all the way to calculus. All right, let's take a look at question 26. If f of x is 2x squared plus 1/2 x minus 4, we have to find f of negative 1/2. Okay, so what does this mean? What does f of negative 1/2 mean? It simply means you substitute negative 1/2 in all the places where you have x in this function. That is what f of negative 1/2 is, okay? So we have 2 parenthesis square plus 1/2 parenthesis minus 4. Okay, so why do I have the parentheses here? Well, I took out the x's because I want to replace them with a value. The new value of x is 1/2, so we're going to put negative 1/2 in these parentheses right here. Okay, now this problem has now changed into an order of operations problem. Okay, so we're going to use the order of operations to simplify this expression. Now, what is negative 1/2 square? You have to be really careful here. When you're squaring negative 1/2, you square the sign first. Minus times minus is a positive, and you square the top and the bottom. Okay, when you square the numerator, you get 1, because 1 square is 1. And when you square the denominator, you get 4. Okay, and I can write 2 as 2 over 1. So let me just show you the steps I did. Negative 1/2 times negative 1/2. Minus times minus is plus. 1 times 1 is 1. 2 times 2 is 4. Over here, we can just multiply across. When you're multiplying different signs, you always end up with a minus. And then when multiplying fractions, numerator to numerator, 1. Denominator to denominator, 4. 2 times 2. Okay? And then minus 4, we can express that as a fraction as well. Okay, so let's simplify this. This can be written as 2 over 4. We multiply across 2 times 1 and 1 times 4 minus 1 over 4 minus, now I want to ensure that these three terms have the same common denominator. These two already have 4 as a denominator. To change this to a denominator of 4 without changing the number, we'll multiply the numerator and denominator by 4. Okay, so that gives us 4 times 4 in the numerator, which is 16. Let's change the color of that. 16 over 4. Okay, now we can simplify. Now we're going to have negative 2. This becomes 2 minus 1 minus 16. We can write it as a combined fraction since all the denominators are identical. The denominators are all what? The denominators are all 4. Okay, so 2 minus 1 is 1 minus 16 over 4. And then 1 minus 16, we subtract and keep the sign of the bigger of the two, which is negative. So negative 15 over 4 is your final answer. Option letter C. All right, let's take a look at question 27. It says use the graph below to answer the question that follows. Basically, which equation is represented by this graph? So if you take a look at this graph, we know what the roots are. The roots are where the graph cuts the x-axis, okay? So it cuts at 3, that's 3. Kind of hard to see, and this other root right here is negative 2, okay? So what are your roots? Your roots are x equals negative 2 and x equals 3, all right? Now, if I want to apply the zero product property, I have to set these two equal to 0. So to do that, I'll have to add 2 to both sides here. So this quantity becomes x plus 2 equals 0. And then over here, I'll have to subtract 3 from both sides so that we have it's equal to 0, x minus 3 equals 0. All right, so what we're doing in essence is we're working backwards using the reverse of the zero product property. So if this number is 0, this quantity is 0, and this quantity is 0. That follows that their product must also be 0. Okay, now let's simplify this. We just distribute or FOIL this out. First, outer, inner, and last. Okay, so x times x is x squared. Outer, x times minus 3 is negative 3x. Inner, positive 2x. Last, negative 6. If we combine the two middle terms, you will get negative x. Remember, when you're combining numbers with different signs, you subtract and keep the sign of the bigger one, okay? So negative x minus 6 is equal to 0, okay? So the related function is y equals what you got, x squared minus x minus 6 minus x minus 6, okay? All right, now, which of these options is the same as what we just got? X squared minus x minus 6. Our answer is option letter B. Okay, so that's that. All right, let's take a look at question number 28. All right, so let's look at 28. It says use the graph below to answer the question that follows. So we have this region, parabolic inequality, represented by this region right here. It says which of the following inequalities describes the shaded region? Okay, so we can use the method of elimination to take out choices. So what you want to remember first of all is that since the bottom of the inequality is shaded, that means that this inequality is less than or equal to or less than. So which of these two is applicable to this situation? Since the line is solid, then it must be less than or equal to. Okay? That's because we're shading beneath. If you shade above, that's greater than. If you shade beneath or inside the parabola right here, facing downwards, that's less than or less than, okay? And then if you include the line, that's equal to. So based on this observation, we can eliminate any function that does not have this inequality. Okay, so let's see. Oh, we can take out option B because that says greater. Now, next thing we're going to do, we're going to take a look at the roots of this function and see which one matches. Or an even easier way to do this problem is to pick a point, a nice point that falls on the coordinate grid and is also on the curve, and plug it into these inequalities here to see if it satisfies it. Okay, or you can even pick any point in this region right here. But to be more precise, I would like to pick the vertex. If you notice, the vertex, the coordinate of the vertex here is 1. The vertex is 1, comma 1. So if I plug in 1 into any of these inequalities, if it satisfies it, then that's a potential answer, okay? Since I'm on the line, I'm going to be looking at equal to, okay? All right, so let's look at option A. Since we're on the line, we have y. Instead of less than, I'm going to use equal negative x squared minus 2 since we're on the line. If I plug in 1 for x and 1 for y, does it work out? So let's plug in 1 for y. Is 1 equals negative 1 squared minus 2? If we work that out, is 1 equals negative 1 minus 2? Is 1 equal negative 3? The answer is no. So option A is not the answer. All right, let's shift to B. This is just plug and chug. We are going to use y equals negative x squared plus 2x. Oh, there should be a 1 right here. Yeah, 2x. Let's fix that. But that's not going to change anything. If we put an x right here, and when we make this substitution, this is times 1, and then it's still a 2, okay? All right, for the b part, we're going to plug in 1. So is 1 for the y equals negative 1 squared plus 2 times 1. Is that a true or false statement? Well, let's work it out. Is 1 equals negative 1 plus 2? Is 1 equal 1? Yes. So our answer works perfectly. So this looks like the answer. All right, let's go ahead and test option D just to make sure that our answer is in fact correct, okay? So option D, we have y equals negative x squared plus 2x plus 2. Note, I'm using equals here because I'm looking on the line, okay? Plugging 1 is 1 equals negative 1 squared plus 2 times 1 plus 2 is 1 equals negative 1 plus 2 plus 2 is 4 is 1 equals to positive 3? The answer is no. So we can see that the answer is option letter C. All right, let's take a look at question 29. It says, which of the following expressions should be placed in each set of parentheses below in order to solve the equation by completing the square? So there's something you never want to forget. To complete the square, you add b over 2 square. That's how you complete the square. Okay? Add b over 2 square. Now in this case, what is b? You take a look at the quadratic expression in standard form. A is the coefficient of the square, b is the coefficient of x, and c is a constant that we add to complete the square. Okay? So in this problem, a is equal to 1, b is equal to 6, and c is what we're looking for so that we have a complete, a perfect square trinomial. Okay? All right, so to find a number that completes the square, we need b first. B is equal to 6. Now we're going to divide it by 2. B over 2 is going to be 6 over 2, which is 3. And then we're going to square that. I get 9. So that's what we're going to add to both sides, okay? So c is equal to 9. That tells us that our final answer is 9. That's what you add to both sides. Okay, let's move along to the last question. It says, which of the following expressions appear as a step in solving 3x squared equals x minus 5 using the quadratic formula? Now, one thing you have to note is that before you use the quadratic formula, your quadratic equation must be in standard form. What is the standard form? Well, that's the form I have right here. Okay? Ax squared plus bx plus c equal to 0. All right, so that's important. And then there goes your quadratic formula right there. Remember that this will be included in the formula sheet that you will be provided with during the test, okay? So this will be included. All right, so to get started with applying the quadratic formula, what must we do first? We have 3x squared equals x minus 5. Is this in standard form? The answer is no. We need all the terms in descending order of degrees on one side of the equation and equal to 0. Okay? All right, now let's go ahead and do that. To accomplish that, I'm going to subtract x from both sides. Okay, and then I'll also add 5 to both sides. Okay, so that we have it equal to 0. Let's go ahead and add that up. On the left side, we have 3x squared, that comes first since it's the biggest degree, minus x, that's the first degree term, plus 5, that's the constant for the 0th degree term. This side just reduces to 0. All right, we now have it in standard form. A is equal to 3. That's the coefficient of the square. B is equal to -1. That's the coefficient of x. And C is equal to 5. Okay, now we're just going to plug in these into the quadratic formula. So we have x equals -b, which is minus 1. You have to be really careful with the sign. Okay, don't lose it. Plus or minus the square root of b squared, which is -1 squared, minus 4 times a, which is 3, times c, which is positive 5. All right, and then that's divided by 2a. A is 3, right? So we have 2 times 6. Now, one strategy to use to avoid making mistakes with your sign is by always using parentheses when you're substituting values in for the letters in the quadratic formula. Okay, if you cultivate that habit, you'll be less likely to make mistakes with your signs. Okay, so let's go ahead and finish this up. We have x equals 1 plus or minus the square root. Now using order of operations here, 1 squared is just 1. 4 times 3 is 12 times 5 is 60. Minus 60 over 6. And then your final answer is going to be 1 plus or minus the square root of 15, actually negative 59 over 6. All right, so final result is option letter D. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to our channel for updates to the remainder of this review series and other cool math tutorials. If there are any questions you have about this lesson or would like to request videos for us to make for you in math, feel free to include it in the comments section below. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.